So the first question here is, if the roots of the equation ax square plus bx plus c is equal to 0 are in the ratio m is to n, then the possible options are given. So the let alpha comma beta be the roots of the equation. Ax square plus bx plus c equals to 0. So these are in the ratio m is to n. So we can have alpha is equals to m times r and beta is equals to n times r, where r is any real number. So alpha plus beta is equals to mr plus nr is equals to m plus n times r is equals to minus b by c, and the product of the roots alpha times beta is equals to mr times nr is equals to mn r square is equals to c by a. Sorry, here it is minus b by a. So from equation 1 and 2 we will eliminate r, so we will get mn times b square by a square m plus n square is equals to c by a. So we will get mn b square is equals to c times a times m plus n square. So the first option is correct. Now moving to the next question. The domain of the definition of the function where y is equals to 3 times e raised to the power x square minus 1 times log x minus 1. So we will first be finding the domain of the function e raised to the power x square minus 1. So the domain of this function will be x square minus 1 greater than equals to 0. So the domain of this function will be x belongs to minus infinity to minus 1 union 1 to infinity, and the domain of this function log x minus 1 will be x minus 1 greater than 0. So the domain of this function will be x belongs to 1 to infinity. So the domain of y is equals to 3 times e raised to the power x square minus 1 times log x minus 1 will be the union of these two domains. So it is 1 to infinity, which is the first option. A is correct answer. Now moving to the next question. Here the question is, the value of integral minus 1 to 1 x minus greatest integer function x dx. So here it is given minus 1 to 1 x minus gi of x dx. So this is nothing but minus 1 to 1 fractional part of x dx. As we know, the fractional part function is the graph of the fraction part function is like this. So we have to find the integral from minus 1 to 1. So it is nothing but the area under the curve, this and this. So this is 1 and this length is also 1. So the area will be half base into height, it is equals to half. So we have to find the integral from -1 to 1, so times 2, because two triangles are counted, so the area is 1 unit square. So the option B is the correct answer. Now moving to the fourth question. So fourth question here is a flag staff of 5-meter high stands on a building of 25 meters high. For an observer at the height of 30 meters, the flag staff and the building subtend equal angles. The distance of the observer from the top of the flag staff is, so it is given the flag staff is on the building of the height 25 meters, so it is the building of 25 meters, and then we have a flag staff of 5 meters. And the observer is at the height of 30 meter, so this is 30 meter. And the flag staff and the building subtend the equal angle, so let the equal angle be alpha, then we can have this angle be alpha and this angle be alpha. Let this distance be x. Now tan alpha is equals to 5 by x, and tan 2 alpha is equals to 30 by x. So we will have 2 tan alpha divided by 1 minus tan square alpha is equals to 30 by x, 10 by x, 1 minus 25 by x square is equals to 30 by x. From here, when we solve x, the x will be 5 times under root 3 by 2 meters. So the answer is 5 times under root 3 by 2. So just we have to find the distance of the observer from the top of the flag staff. So this distance and this distance is the same. So the answer is this. B is the correct answer. Now moving to the next question. If R is equals to, R is defined as x comma y belongs to z, meaning integers, and the condition is x square plus y square is less than equals to 4. So we can see that x and y can be from the set -2, -1, 0, 1 and 2. So these are the only possible value for this condition to satisfy x square plus y square less than equals to 4. So the domain of R will be C.